Some of you saw my last video on the custom web search agent that I made with LangGraph. That video was essentially a tutorial about LangGraph, trying to explain the key concepts to make it easy for you to understand the framework. And then I demonstrated the custom web search agent that I designed with the LangGraph framework at the end of the video. Since then, I've been testing the agent and I have found a few things that I could improve. So I've gone through and made a lot of amendments to the custom web search agent. And in this video, I want to talk you through some of the changes I made. There's two purposes for this: to share with you my approach and my thought process on how to improve the agent, to be open and honest about the bug fixes I've made, and also to get some open feedback about the approach and how you would do things differently if you would at all. So stay tuned if you're interested in seeing this. This is going to be fairly technical. I'm going to go deep dive into Python code. So if you're interested in seeing that, this will be for you. If you haven't seen my first video on the LangGraph agent and you want to understand how the LangGraph framework works, I would suggest you watch that before continuing on with this one. If you already are comfortable with LangGraph and the key concepts, you're probably fine to continue on watching this. I want to give a high-level summary of all of the changes I've made. So this is what you can see on screen now. So the first one is Atomized Workflow. So I've discovered that by breaking out the agent workflow into smaller bits or into smaller tasks that are more specialized, I can actually make the overall performance of the system a little bit better for answering some of those more complex questions. Now, I haven't got a rigorous way of testing this. This is really just on gut feel, but I can see the results from the testing that I've done. The second one is refactoring the agents. So I found the agents.py script was getting a bit convoluted with those large functions that I had. So I found that refactoring it made it a lot easier to add additional agents if I want to and build the integrations in with things like Claude, Groq, and Gemini. Third is a minor bug fix. So it was a minor bug fix that I saw on the graph script, and I'll talk through that in detail. The fourth is an integration with Claude, Groq, and Gemini. And I'll show you how I did that. I did a video previously talking about how to integrate, but it's actually easier now that I've made those changes that I've just discussed. The fifth is a front end. So I built a front end to this in Chainlit. So if you don't want to work in the command prompt or in the PowerShell, now you have a nice front end that you can work with. And last of all on the agenda, I'm going to demo the agent to you so you can see how it works with the front end and with one of the integration services. Maybe we'll use Gemini. All right, let's start with the Atomized agent workflow, and I'll talk through my reasoning and logic for doing it the way I've done it, and I'll show you how I've integrated that into Python code. If you watch my previous video, this diagram should look familiar to you. So this is the previous setup that I had, and I'll run through it really quickly just to give you a reminder. But basically, you get your input query. It goes to the planner. The planner's job is to find the web search, the appropriate web search terms for that. That's passed into the web search tool that actually conducts the search and returns a search engine results page. The researcher is to pick that up and select the best source from that search engine results page. That's passed to a scraping tool. The information is scraped from the web search, the web URL from the researcher. So the information is scraped here. That's passed to a reporter who generates an answer, and then the reviewer. And here's where things got tricky. The reviewer actually had a few jobs here. First of all, it had to analyze the report from the reporter, and it had some set criteria that I had established to make sure that the reporter was reporting at the right quality. Secondly, it had to decide whether or not the report passed the quality assurance. And then thirdly, if it had passed the quality assurance, it would route to a final report. And you can see that arrow there following that. Or it would route back to one of the agents in the pipeline. And that would depend on exactly what needed to change in the report. So depending on, if there was a formatting issue, it might route back to the reporter. So the reporter can deliver the answer in a different format and it'll provide some feedback. If there was an issue with the source, it would route back to the researcher. If there was an issue with the actual method or if there was additional data sources, it should route back to the planner. So ultimately, the reviewer was doing a lot. There was actually so much that the reviewer was asked to do. And I found that when it came to more complex questions, the reviewer just could not handle it. The reviewer would just always default to routing back to the researcher. And that was obviously causing some issues. So what I found was that atomizing this and breaking up the role of the reviewer into two agents made a big difference to the ability of this overall workflow to answer more complex questions. I'll show you what that looks like. So what I have here now is the reviewer still conducts the quality assurance, but it doesn't have the job of actually routing back to an agent in the workflow. That is separated out into a separate router agent. And the sole purpose of that router agent is once the reviewer has delivered its quality assurance assessment, the router can pick that up and based on the feedback from the reviewer, decide which agent is the best to actually conduct or operate on that feedback. So like I was saying before, if there needs to be additional information, we'll go back to the planner. If there needs to be a different source, we'll go back to the selector. And I'll talk about why I changed the name from researcher to selector. If there needs to be a different format, we'll go back to the reporter. I also changed the name of this agent from researcher to selector because I got the sense that by calling it researcher, it implies that it's able to actually go and discover sources, which is not the case actually. It's the planner that actually comes up with the search terms that actually then delivers us the sources. And then the selector just selects from the sources available. So I found that maybe calling it researcher was misleading the agent a little bit. So by calling it selector, I wanted to bypass that problem. So this is atomized in the sense that the reviewer and the router now do the job that the reviewer was just doing before. And the rest of the agent workflow continues as normal. So there's a few places in the Python code that I've made this change. Obviously in the graphs script where we actually construct this graph that you see on screen, but also in the prompt script and in the agent script. Right, I'm going to do a walkthrough of the 4 scripts that I needed to change to implement this new atomized workflow for the agent. So the first script obviously here is the prompt script. So I want you to pay attention to something. I don't know if you can see here on the right-hand side, everything that's commented out in green here. And I don't know if I can zoom in. If I zoom in more, yes, it does. So everything you see commented in green here was previously the reviewer prompt. So you can see relatively to the other prompts, it's huge. It almost takes up a quarter of this script. And it was way too complex, as I explained previously, and ultimately was leading the reviewer to get confused. Also, when you're working with models that have a smaller context, like Llama 3, for example, this isn't really good. This means that you can't really work with those models. So the reviewer needed to change. I needed to atomize that a little bit. All of the other agents stayed the same. All I did was I broke out the reviewer. So now you could see previously there's where it was routing, there's where it was told about its criteria. And then you can see the part where we asked to route to a different agent. And all of this was there to help the reviewer or guide the reviewer to not only create a criteria for actually assessing the quality of the reporter's response, but also to route it. And there's a lot there, too much. In contrast, this is the new reviewer prompt. So you can see it's much simpler. There's a lot less inputs, and really it only has one job, and that's to fulfill this quality assessment. So what I found is that the quality assessment itself can be a little bit more straightforward, and it's better. I can prompt it more in the direction of quality assessment, so it only has that one task. And then what you have after that is, whoops, I've just seen a bug here, so I'll get rid of that. So that should not actually be required anymore. All I did there, by the way, was this is the JSON schema. And when you're using something like VLLM, or where you want the model to return a JSON, you have to provide it with a JSON schema. And I realized that we're no longer asking it to do the routing here. So we're no longer asking it to suggest the next agent. So I need to get rid of that, and that's fine. So that's a minor bug fix there on the fly. Okay. So moving on to the router prompts template. This only has one job, and the job is based on the feedback from the reviewer. You choose the right agent to route the response to, and there's some criteria here. I'm not going to go into reading all of the criteria. You can do that in your own time because the GitHub repository for this code is available in the description to this video. So you can check that out and do that in your own time. So I'm not going to go into the criteria in detail, but you review that for yourself and see if it makes sense to you. That's the prompts. So I forgot to mention in my intro to this section that we did also have to make a change to the state. And the reason being is, if you recall, that every agent writes to the state. So I needed to provide a state that the router could write to. So I'll show you where I've done that. It's pretty simple. The first thing is to make the definition in the state object. So this is the agent graph state object. So you can see here, I've just added that router response in there. And just making sure that's also captured in my state dictionary too. So that's a relatively simple change to make. The next change is obviously to add a router agent. Now, I'm going to show you the agents.py script. I'm not going to talk through everything there. I'm just going to show you where I added the router. But in the next section, I'm going to go into more detail about the agents.py script because I have refactored that. So that will come up in the next section. So let's navigate to agents.py, and I'll show you where I have brought in the router. So after the review agent, now you have a router agent. And lastly, we need to include that in our agent graph definition. So you can see where we are adding nodes to the graph. I'll take it from the top just so you get a holistic view of the script. So we have this function to create a graph. And when we're creating the graph, we're really just adding those nodes and edges. So you can see where we're adding the planner, selector, reporter, reviewer, and now we also add the router to the graph. And everything else remains the same. And the next thing is also to define the edges. So I'll show you where I've defined those edges. So everything remains the same up until the point in which we get the reporter. So now the reporter talks to the reviewer, and the reviewer then talks to the router. And then there's conditional edges with the router. So depending on what the router decides, we will navigate back to either the planner, the selector, or the reporter, or we'll navigate to the final report. And that's based on that conditional diagram that I showed you briefly in the last section. And that is it. Those are all of the changes I needed to make in order to atomize my workflow a bit more. And like I said, I've seen a slight uptick in performance by doing that. Let me know in the comments section if you have any suggestions about a workflow. If you have any criticism about the workflow, it'd be interesting to get your thoughts on it. So what I have open now is the agents.py script. And this is the agents.py script as it was before I made the refactor. So I just want to talk through what I believe is wrong with this. So as I started to add more services, I realized that having these agents as functions was not really going to cut it. Every time I needed to add a service to this, so I'll show you what I mean by service. So if I'm using OpenAI, for example, that's one service, or if I'm using Ollama or VLLM. So as you can imagine now, I've also added Claude, Groq, etc. Every time I needed to add a service, the way I had this thing set up was that in each agent, I would have to go through and add this conditional statement to pull through the correct large language model that corresponded to the service. So you can see for the planner agent, I have this function and I've got my service conditions here. And then moving on for the researcher agent and so on and so forth for every single agent in this script. I'm adding that service. You can see here, for the reviewer too. So there's a few things about this. It just makes the script unwieldy after some time. You imagine you can add services almost indefinitely with the rate that large language model services are coming out. So this script grows over time and it becomes a nightmare to update. And as well, it's harder if I want to add a different agent. I have to create these functions all again and add that agent. And you'll notice here that, a lot of these things are shared across agents. And that's kind of where the refactor came in. I'm going to talk a little bit more in detail about that because every agent needs to pick a service. Every agent also needs to invoke the large language model, although they are invoked in slightly different ways. And also the state. Every agent takes the state. Every agent takes most of these parameters that we see up here, or all of these parameters that we see up here, bar a few parameters that are specific to the type of agent we're dealing with. So, for example, only the planner agent takes the planner prompt template. The other agents will take their own corresponding prompt templates, but every agent takes the research question. Every agent takes the model. Every agent takes the guided JSON, stop, etc. So having these things set up as different functions in this way just made it more convoluted to make changes to any agent. So adding services or adding additional arguments that I would like the agents to take on. So for example, if I wanted to add temperature in here, I'd have to go through and do that for every single agent in this script. This is the old way. I'm going to talk through some of the theory about the refactor next, and then I'm going to show you how I implemented the refactor in the agents.py script that I'm currently working with. All right, I want to talk through the methodology of the refactor. So long story short, what I did was instead of having those agents defined as functions, as I showed you previously, I've decided to define an overall base agent class and then define the agents as children that inherit from that overall base agent class. And I'll get into details of that. So what I understood from my code is that the agent, there is a base agent, and that base agent, no matter what type of agent you are, whether you are a reviewer, planner, selector, router, or reporter, there are a few functionalities that you just want to do. So all of these agents have these functionalities in common. So the first one is obviously updating the state. And the second one is to get an LLM service, right? So any agent, no matter what they are, will update their state and get an LLM service. So I have an agent class that does exactly that. So this is a base agent class. And this is what I'll refer to as a parent, right? So this is the parent object or the parent class. Then you have the children. So the children inherit the method of the parent class. They also inherit attributes as well. The attributes are things like, I haven't put those on this chart, but attributes are things like temperature and all of that type of stuff. And you'll see that in the code when I show you. But what you should think is the parent class has the attributes that it wants to pass on to every other child, and those children inherit those attributes. So every child here can do the following: update the state, and also get an LLM. So what that means is when you want to add an additional attribute to every single agent here, you just need to change it at the base agent level. And every single agent can take on that attribute instead of having to change it for every agent individually. So the reviewer agent can get an LLM based on the service it's using, and it can also update its state. And so can the planner, selector, router, and reporter. So these are the children of that parent agent class. So where the difference is between the children is that they invoke their LLMs in slightly different ways. And that's due to the prompt templates they're using. So where we're invoking the LLM, we have a child class, and we have a separate invoke method within that child class. I'm going to show you what that looks like in the Python code next, but hopefully this explanation of the refactor makes sense, and hopefully it will make even more sense when you see the Python code. So you should see the Python code on screen now. And you can see the base agent class that I've defined. And there are a few attributes here. So every child agent is going to have these attributes. So things like state, the model, the server, the temperature, model endpoint, stop tokens, guided JSON. These are attributes I would like every child that inherits from this parent agent to have. If we want to add another attribute, all I need to do is add it here in the agent, in the parent agent, and that's going to be transmitted to, or it's going to be transmitted to the child agents through inheritance, right? So those are the attributes of the parent agent. And then we have the methods, right? So we talked about this, get LLM. Every child agent, every child of this parent needs to be able to get an LLM service. So now if I want to add an additional LLM service, all I need to do is add it at the parent agent level. That's all I need to do. So I just need to come in and add. So I have Claude here, Gemini, Groq, VLLM, Ollama, OpenAI. If I wanted to add Mistral AI, all I need to do is add it at the parent level. And then finally, updating the state. So we know that every child agent will update its state. So this base parent agent that every child agent inherits from can also update the state. Let's see how that works. So if we go into the planner agent is inheriting from the base agent. It has its own method of invoke because, like I said, every child agent invokes its LLM slightly differently because they have different prompt templates. There's different variables that feed into those prompt templates. They're prompted in slightly different ways. But then, as you can see, once we get our LLM, and that's a standard for every child agent because it's inherited from that base agent class, then we can invoke, and then we can also update. So that update comes from the parent. And you'll see this is similar for every single agent below this point. So the selector agent, it's invoked slightly differently. So that invoke class actually looks a bit different to the planner. And that's based on the prompts. But this is similar. So we're getting our LLM, which is from the parent agent. And then we are updating the state. And just to make you comfortable, I'll show you what that looks like for the others. So it's the same. We get our LLM service, and then we update the state. And the reviewer agent is the same, and the router agent is the same. So to add a new agent, all you would have to do is create a new class that inherits from the top, from the parent agent. And your invoke method would be slightly different depending on what you want that agent to do. But all of this stuff here would remain the same. The only thing that is slightly different is printing the response. So obviously you want to print the response aligned to the name of the agent that you are printing the response from. That's the only thing that's slightly different, but everything else is much simpler to update. So that's the refactor. I believe this refactor just makes it a bit easier to manage and maintain this code, and also, add new agents and add new attributes to agents if you need to. I want to talk about a bug that I discovered in the graph.py script. So to give you an overview, what I was noticing is when I was asking questions to the agent, like what is the current weather forecast, for example, I found that it was navigating, finding a source for the current weather forecast, but the weather itself was hallucinated. It wasn't matching the weather on the website. And I thought that was interesting because I could definitely see the agent workflow finding the correct source, but it seemed like it wasn't picking up the right weather from the weather forecast. And I was kind of racking my head, what could be causing this? And I discovered that the input into the reporter was not correct. So you can see here, the reporter actually takes on the responsibility of generating that response. So if you ask a question like, what's the current weather? If you remember the diagram, what would happen is that the first the planner would come up with a search engine term. You'd go into the search engine, return a search engine results page. Then what is now the selector would select the best URL to answer the query. And then that would pass to the scraper tool. The scraper tool would return some scraped content from that URL. And then that is supposed to be passed to the reporter, from which you can use to generate a response. What was actually happening, or what is actually happening here, is that the research, which is meant to be the response from the scraper tool, is actually just the output from the what is now the selector. So essentially what I was returning to the reporter was the URL and a description of that URL, not the actual contents of the URL. So that's a minor bug fix, and I have since corrected that. I'll pull that up. So this is the researcher as I have made the change. Apologies, this is the reporter as I've made the change. So where you can see the research now, it now pulls from the scraper. So the scrape data, the website content will now be in the context of the research of the reporter, and the reporter can deliver a response on that basis. That's the bug fix. It was a minor change, but it has serious implications. So I wanted to be transparent with you and show you that that has been resolved. Let's talk through the additional services that are integrated into this custom web search agent. So what you have is the models module. And I've gone into detail about how to integrate other services. I did a video on integrating Ollama and VLLM self-hosted service. But I'm going to run through it briefly again, because it's relatively simple to bring in your own service. If you want to bring in Mistral AI, for example, that's a service I haven't yet integrated. But what you'll do is you'll navigate to the models module and you'll create a new Python file for the service you want to bring in. And I've got some naming convention here. So I just give it the name of the service _models. Let's pull up Claude as an example. So I have two classes here. I have a Claude JSON model, which is responsible for returning JSON outputs. And I have a Claude model, which just returns normal tokens. When you're integrating a new service, I like to use the request library. And the reason I like to use the request library, so I make an API call rather than using the wrapper that a lot of these services offer you. I prefer to do it this way because I don't need to go into the requirements.txt and add another library to install. And also the request library kind of follows this general format that I can easily adapt for other services. And the general format is to obviously define your headers. And this looks different for every service. Some services require you to have the API key defined within the header. Some services require you to have the API key defined in the endpoint. But yeah, you define your headers. You get your API key for the service if one is required. You get your endpoint. And then you get your payload. And this is how you make that post request to your large language model service. And then once you've made that post request successfully, you'll get a response and you just decide how you pass that response. And every service passes the response in a slightly different way. If you really want to know more details about this, I've done a detailed video on integrating new services into the script. Even with the refactors and all of that stuff, the philosophy really hasn't changed. So if I were you, I would definitely go check that video out. If you're interested in using the script for yourself and integrating a different service that's not already available to you. So far, I have Claude, Gemini, Groq, Ollama, OpenAI, and also VLLM, where you host your own large language model from Hugging Face. So VLLM works with most Hugging Face models. You just need a rent a GPU service. I like to use RunPod, but there are other services out there where you can host your VLLM inference server, and then you can use this script, or you can use this project with your own self-hosted VLLM inference server. Before I get into a demo, I want to talk a little bit about the front-end script that I've written. So I've written this front-end script using a module called Chainlit, and I found Chainlit to be useful working with clients, especially when I want to build a quick demo or an MVP. Chainlit makes it really easy. It's specifically designed for large language model chat-based applications. So you have the chat interface already there for you, and you'll see that in the demo in the next section. Streamlit, I found a bit more difficult to get going with chat-based applications. I know some people are quite skilled with building chat-based applications in Streamlit, but Chainlit kind of abstracts a lot of that stuff away from you. So it's my go-to for building any type of chat-based application if I want to build something quickly, a demo for a client or an MVP for a client, for example. So that is Chainlit. There are a few key concepts. So I have got some functions here that are, helper functions for writing API keys, and also got this class here. And the only thing this class does really is build the workflow. So that's the agent workflow that I've been talking through. It builds that workflow, gets everything set up, and then it invokes it. So that's the only thing this class does. You can look at this in your own time because this is really focused on the front end rather than the specific way I've set up my class to run for this front end. But if you take a look at the script, it should all be obvious to you what's happening. So there's a few key concepts with Chainlit. They have a few decorators here. So the first one is on chat start. So this function occurs when you set up a chat. So whenever you initiate a new chat, and I'll show you how to do that when I'm doing the demo, this is the function that kicks off. The second one is on settings update. So there are times where we would like to select a different large language model service, or we want to select a different model, or we want to adjust temperature. We'll be updating the settings menu. So this is what kicks off when we update the settings menu. And this is important because there's some key variables here that we set that we want to pass to our agent workflow. So obviously, every time the settings menu updates, we want to make sure those variables update too. So that's what's going on here. And the third one is on message. So every time we send a message to the agent workflow, we want certain things to happen. So we want to actually invoke our agent workflow every time we send a message. So the message is like the research question. And this is where that all happens. So those are the three areas. I'll start from here. So on chat start, what we have here is a menu. Sorry, not a menu, a settings panel. And we use a Chainlit settings object or Chainlit settings class to define that settings panel. And it's really simple. You would have seen things like this before. There's the option to have like a select panel where it gives you some options like OpenAI, Ollama, and these are set options that you choose from. You'll see that in the demo. Number input. So if you want to input a number, I've got a recursion limit number here. Text input. So all the API keys are inputted via text input. And then there's a slider as well. So you can control the temperature of any model with a slider. Settings update is pretty straightforward. All we're doing is we're allocating variables from the settings that have been set in the settings menu. And those are passed to the workflow. So when we build that workflow, it takes on all of the settings. So if we're using the Groq service, for example, we'd have the Groq API key. And we would also have, we'll configure that. We'd also have the server, would have the model we're using as well. All of these settings, all of these parameters are set via the settings menu and they pass when we're building the workflow. So every time we change the settings, we're rebuilding that workflow based on those settings. And then on message. So every time we send a message to the system, every time we send a message to the agent workflow, it goes through and it invokes that agent workflow. And you can see the message being sent through there. That's Chainlit in a nutshell. So really simple to build what looks like quite an elaborate chat interface. Next, I'm going to demo to you that chat interface. We'll probably use Gemini. I'll talk through my experiences with Groq. I'll talk through my experiences with Gemini, with Claude, and also with OpenAI. Right, I'm going to show you how to get up and running with the front end and demo the agency using Gemini. So what I have is I have these two files, run linux.sh and run windows.ps1. And kind of self-explanatory from the names of the files. One is for if you're running in Windows, and the other one is if you're running in Linux or Mac. So I don't have a Mac. I do have a Linux shell. So I can test the Linux shell there, but I can't test on Mac. So just let me know in the comments if there's any issues running on Mac, and if anyone else can help out with getting this to run on Mac, that would be appreciated, but I believe it should run. So all we're doing here is, we're just setting the working directory, and then we're running the chat module through Chainlit, using Chainlit. And this option gives us the ability to make changes to the front end script, and that will refresh the front end without us having to close the Chainlit server to do that. So if you're developing on this stuff locally, this option is useful. To get up and running, if you're going to follow my approach, all you'll need to do is run windows.ps1. If you're on Windows, you're running this in a PowerShell, obviously make sure your environment is activated and all of that stuff. And that will take some time, and it will load up Chainlit on a locally hosted web server for you. And there you go. That is the front end. And I'll show you the settings menu. So you pull that up. You have the ability to select the server you want. So we're going to go with Gemini. You have the ability to set the recursion limit. So this is literally how many times the agents work. So the agents will take a maximum of 40 steps here. Obviously, for more complex questions that require multiple steps and might require multiple feedback loops, you might want to increase the recursion limit. But for simpler questions, it won't get up to 40. You need a SERPA dev API key. If you're using OpenAI, obviously you'll select an OpenAI API key, but I'm not using OpenAI, so I'll leave that blank. Same with Groq. I'm not using Groq, so I'll leave that blank. Same with Claude. It's Gemini we're using, so I'll set a Gemini API key. And don't worry, I'm going to revoke this by the time this is published. Enter your model name. So it's important that you enter the model name exactly as it says on the documentation for the service you're using. So we're going to use Gemini Pro 1.5. You don't need to enter a VLLM endpoint because you're not doing self-hosted. If you're working with Gemini, you're using a Gemini service. The stop token is only necessary as well if you're using the VLLM endpoint. Temperature you can set here, but it's defaulted at 0. And then you can hit confirm. Once you see workflow successfully built, you can ask your question. And what I'm going to do is I'm going to show you the backend, because you'll see simultaneously how when we ask a question, the backend is actually working through that agent workflow. So let's ask something really simple to start off with. What is the capital of the UK? Ask something very simple. So that's working through, and you can see the backend working. You can see the planner going through a search term, and you can see the reviewer, and then we've got a final response. So you can still monitor how the agents work on the backend here, and that will be in your shell or in your PowerShell or your terminal, whatever you're using. And then you have this based on the information gathered. Here's a comprehensive response. So the capital of the United Kingdom is London. And you have your source here. We can try it with a different model. So let's try with the Claude model. So instead of using Gemini, let's go on to use Claude. SERPA dev API key remains the same. This time round, we want to enter the API key for Claude. So we'll select that, and we need to change the model. So we'll be using the Claude Opus model, and we'll hit confirm on that. So as a workflow successfully built. And you can see here, it even tells you what model you're using. So we used Gemini Pro last time. Let's ask the same question. What is the capital of the UK? And hopefully if there are no errors here, which fingers crossed, because this is a live demo, we should get a response from Claude. So you can see it's working through with Claude. You can see the planner there. Claude is a bit slower than some of the other state-of-the-art models I've noticed. And it's a lot more verbose as well, and you'll see that. I think obviously the fastest is Groq, but I'll get onto issues with Groq shortly. So you can see here, we're working through, and this is the back end. There we go. So there's our response with Claude. A lot more detailed. Citations referenced at different points as well, which might or might not be important for your use case. You can compare that to what we returned with Gemini 1.5. So notice it's exactly the same workflow, but just different LLM agents. You can do the same thing with OpenAI. So get onto, can select OpenAI. And your SERPA dev key. So this time around, we want to make sure we're selecting the OpenAI key. I'm going to revoke all of these before this is published, obviously. And then you want to select your model. So make sure you are selecting an OpenAI model. Hit confirm. You have your workflow built successfully. And then let us go on to ask a question. Let's ask the same thing. What is the capital of the UK? And yeah, you'll see the workflow working through quickly here. Planner, selector, reporter, and then we deliver a response. So there we go. So less halfway between what we delivered from Claude versus what we delivered from Gemini Pro. Now, you might be asking why I'm not demoing Groq. The reason I'm not demoing Groq is I'm on this free service for Groq, and I hit the rate limits as soon as I use this workflow. So it doesn't work for me. The Groq integration is there. So if you are on a paid service for Groq and you have extensive rate limits, if you have those extended rate limits, you might be able to use this, but I can't use it with Groq, unfortunately. So it is built in there, but it's not worth demoing. There's a few other things to be aware of. I haven't yet built in a functionality to stop this here. So you do get the option to stop it, but I haven't built that functionality in here. So stopping it at this point isn't going to do anything. Your workflow will still continue on the back end. If you really want to stop it, you need to go to the back end and cancel the server on the back end here. I will think about building something in, time permitting here, but just to let you know that that's the case. Also, this is obviously only text, interpreting text, so you can't, there's no room for like updating, there's no room for attaching documents here or anything. It does have it on the UI, but it won't do anything because I haven't put any of that in the back end. So bear that in mind too. Even though the option comes up here, you can't actually attach a UI. If you would like me to do something on model comparisons with this agent workflow, so comparing some open source models with Claude and benchmarking it against Perplexity, let's say, let me know, because I'm going to come up with some interesting questions that I think are going to be hard for any of these models to answer without an agent workflow. So that should be interesting, because I'll admit GPT-4o is really good. It's really good at answering those multi-hop questions by itself, but it does get them wrong sometimes. So I'm thinking for my next video, I'll come up with a list of questions, maybe just 4 questions that are especially tricky for those models to answer by themselves, and see how well they do once they're incorporated into this agent workflow. So let me know if that video interests you. If you like this content, subscribe to the channel for more large language model and AI engineering content. Give us a thumbs up. Give us your opinions in the comment section. And I look forward to seeing you on the next video.